So let me ask you this, Matt. I'm just, and this is just for me. I'm kind of curious on this.
Mm-hmm.
Let me throw this scenario at you.
Okay.
Matt, this is science talking to you. We have confirmation that the Earth is flat. What goes through Matt's mind?
Good question. The very first thing that goes through my mind is, you're pulling my leg. This got to be a joke. After that, I'm going to say, I'm going to need to pause and reflect, because I've also been studying flat Earth since 2016 when I heard about it too. And I have done many tests. They've all confirmed the globe, all of them. And so now I'm going to need whoever this is telling me, I'm going to need you to go through these tests with me, the ones that I've done, and explain to me my mistake. I mean, like I try to do with you tonight. I went through your stuff. I believe I found a mistake in it. And so I would need them to do that same thing with me. Is how does this observation match what you're telling me? How does this observation match what you're telling me? Yeah, I mean, I went to grad school at NASA. I was in aero, but some of my buds were in astro. And we were tracking satellites. So they were, you know, I was a consultant on their software, but we're tracking satellites. You know, I'm going to need some help figuring out how that all worked.
Sure.
Right. So, right. Or like equatorial mounts. You know what an equatorial mount is on a telescope?
Go ahead and explain it to me, because
okay. Regular old home astronomers often will get these. So this is just like regular folks.
Okay.
It's just a mount for your telescope that you know, when you have to watch the stars going up and down, and you also have to watch side to side. So that's an azimuthal, right? Azimuth and elevation.
Gotcha.
That's your classic mount. But if instead of doing it this way, you tilt the whole thing, just tilt the mount to 23.5 degrees, right? And you point the one axis, you point it straight at the North Star, or well, straight at north, which is a little bit off the North Star. Now you can follow any star just by rotating on one axis.
Oh yeah.
Okay, so they call that an equatorial mount.
Okay. Thanks for explaining that.
For example, if you were to watch the sun with an equatorial mount, you would see that it moves at precisely 15 degrees per hour. Well, actually, it's a little different. It's no, it's 15 degrees per hour for the sun. Yeah. 15 degrees per hour for the sun. It's a little different for the stars. And it will just move on that one axis at 15 degrees per hour. But you'll see, I'm just looking at the telescope, it's not moving this way, right? That's the elevation. It's moving like this, 15 degrees per hour. Right? And so in the morning, and you leave it running at night, like it is night right now. Where's the sun? It's down there. Right. Keep going. That's what it's doing. And you can watch the equatorial mount point through the floor and then come up in the morning, bang on, right? So how's that even work? Right? If the Earth is flat and the sun's actually doing this, right? The sun's actually doing that. How does this thing track it?
Your azimuth would tell you that.
Yeah. So yeah.
The orbital mechanics work for the flat Earth model. In other words, meets the height. Yeah, they do.
No. Why don't you come back? Why don't you come back and do a presentation on how orbital mechanics can work, or like how the sun works from any pick? If you tell me,
do you have the Flat Earth Sun and Moon Zodiac app?
No, I don't.
Try it.
I don't, but it's pretty hilarious because it's completely wrong. Like, you point to where you think the sun is right now. And the flat Earth, isn't the sun to the north of us right now? Flat Earth model, the sun should be there.
You're talking about it's wintertime and the sun is to the north?
Yeah, isn't that right? At night. Where does the sun go on the flat Earth?
It just goes out of your visual perspective, and it goes orbit
But where?
a circle over the flat Earth. So it's going to go out of your
So
visual.
if it must be to the north of you somewhere, right?
Yeah, it would be. Yeah, you could say that on the flat Earth model. Yeah, because north
And
the flat
where
Earth
would the
model
sun
is
rise?
center. It's
Where
like a
would the
dinner
sun
plate.
be?
It's like
Where
a
would
dinner
the sun be at sunrise?
Huh?
At sunrise, where
Okay,
would
comes
the
back
sun be?
around in a circle. Comes back around, and it comes back into easterly.
It's going like this, right? So still north.
Now it comes back around.
It goes
It'll
from
come back around.
the other side of the Earth.
It comes back around in your visual
Comes
perspective.
around to behind me, right? It goes like that.
Mhm.
So at
That's
sunrise,
what you see across your sky. You see that sun move across you in the sky in the daytime. That's pretty simple.
Yeah.
It's too easy.
it's interesting that that you've been. What I find interesting is you've been very critical about the exact angle of the sun compared to the globe model, and never critical about the exact angle of the sun on the flat Earth model.
That's because it's so easy. It has such a high tolerance. It has such a high.
No, what I'm telling you is it can be 90 degrees out of position. It's just like colossally wrong. The flat Earth model, depending on where you do these observations, it's amazing that you've never even looked.
Oh, it's too easy because again, you have to go back to that diagram.
So easy that you've never done it.
You have lower sun angles. The closer you are, you're going to be closer. So that sun, as it's seasonal, as it changes in the tropics, as it gets closer, you're going to have higher sun angle. As it moves away, you're going to have lower sun angle. That's too easy, Matt. Come on.
What about the azimuth, though? I'm talking about the azimuth of the sun.
Again, as far as what left and right or up and down.
Azimuth is
so left and
north,
right.
south, east, west.
So your fan, as it comes across to you, is, let me see if I get this right. So that's going to be your fan. It's going to come at you from the east, come across to the west. I mean, that's too easy. As you'll see,
I want to be precise. I want to know exactly the angle. I want to know if it's, let's say, what time is sunrise? 8 a.m.
Mm-hmm.
Right? Probably more like 7 a.m. I don't know. What time is sunrise for you?
Now?
Yeah, this time of year.
Probably closer to like 7, something like that, maybe later.
So at 7 a.m. on the flat Earth model, where is the sun?
Well, it's still in the tropics.
Well, of course, but it's a circle, right? You make the circle. Go ahead, draw the circle. Say the sun is at midnight. Here's you. Here's the sun, and it's coming around. It's coming around at 7 a.m. It should be there.
Okay. And
that is, this is north. This is south. This is east. That's west. It is northeast. Right? Because it's got to keep coming around, keep coming around. At noon, it's back here. It should be here. Not here, here at sunrise. Well, about like there at sunrise, right? Which is northeast, not southeast.
At sunrise,
it'll be southeast.
And you talk about sunrise now?
Yeah. Where would the sun be at sunrise? What azimuth angle will the sun be at sunrise?
It comes at you at southeast.
But on your model, it's northeast.
No, it's southeast.
It is. Did you have didn't you have you didn't have an Earth on it, but you did have a diagram of it.
Well, look at your Mark's device. Your Mark's device is going to tell you that also. The sun is going to up because you're up in the north.
If the Earth is flat, and you're like here, somewhere on the eastern seaboard, right? at noon, this is almost, that dot there is almost noon. So this dot is 1, 2, 3, 4, 5, 6 hours earlier.
Mm-hmm.
So 6 hours, that's about sunrise. East for you is this way, right? Straight out east.
Mm-hmm.
That's north of east.
Mm-mm.
Yeah, it is.
You're gonna have to move that sun over, because when you're talking about what you see in the sun, that's going to be your south. Your sun comes at you in the southeast.
I know, but not on the flat Earth model. Here's east.
So
This
look
is
at how
east.
far. Look at how far you're looking
That's
at.
east, right? So squiggly line, but it starts. This is east. That's west, right? Here's north. Here's south.
Mm-hmm.
Right?
Yeah.
Look at the freaking sun. Tell me that that's north. That's south of east.
So for one, your sun
That's
is
north of east.
So one, your sun is way too big. So in other words,
Well, of course, yeah.
your sun is going to be the size of about a pinhead. So in other
Okay.
words, you're not going to pick up that sun in your visual perspective till it gets to your southeast. And
What time would that be? That would be here, which is what time? This is 12. Here's 11, 10, 9, 8. So at 8, the sun is due east. But you think maybe the sun rises around 7.
Yeah, it's later, especially now in the winter.
Right. But this dot I just made is north of east.
Well, yeah, that's because you're what meridian are you on? Are you on the equator, or are you at the Tropic of Cancer?
Oh, I believe this is the equator, isn't it? I think this is the equator. So you're actually thinking that since it's the winter, it'll be further out, right? So it'll be
between the equator and the Tropic of
Capricorn. Be here.
Yeah.
A little closer, right? A little closer to due east, but still north of east.
Yeah. So it's gonna, when you pick it up in your visual perspective in the flat Earth, again, you're gonna pick it up as it comes at you at the southeast when it comes into your visual perspective.
The reality is you're gonna see it over here. But the model has it here.
Reality.
So the model's wrong.
Well, you're making a big assumption there.
What I'm saying is that's something you could test, right? You could test it so easy. All you got to do is draw that map like I just did, carefully place yourself on that map, carefully draw a straight line east and west. Draw a straight east-west line.
Can you go back to that map?
Okay, so I have, I believe I'm drawing this at the equinox. This is at the equinox. Right now we're not at the equinox, but you can wait till spring equinox, which is coming up. It's a really good thing to do, by the way. This is one of my 20 tests that I have on my website or my YouTube channel. 20 ways to tell if the Earth is flat or not.
Right. So when we look at the azimuthal equidistance, this is the azimuthal equidistance map. Do we have issues with this map? Yeah, there's some question about whether it's actually accurate. Now,
yep.
I think it's like the Gleason's. Have you seen the Gleason's 1892 map?
Yes.
Okay. So these are kind of what you'll see on the flat Earth map.
Yeah.
Do we believe that the map is accurate? Not so sure. We have issues. We have issues. And again, you bring up a good point about using the sun. The sun, I believe, and this is another application you can use with the sun, and you can do this with multiple or simultaneous observations as far as looking at land masses. You could actually, I believe, actually get a very good map based off of using the sun. You just have to know how to use it. And that deals with azimuths and then intersecting, from observers from different positions. Now, when we look at this map, and can you go back to it just for a second?
Yes.
I believe, and based on Richard E. Byrd, when they kind of found out that this place wasn't all it was cracked up to be, in other words, it was something different, here's how I think the military and the government found out. And that is, how could you tell that we're on something different, but I need somebody to go out there and verify it? In other words, how would you do it? Here's how the military, if you'd had all of your resources, you take communications transponders and you drop them at certain points around the perimeter. You can only get certain azimuths from a directional finder and say, well, if you look at the flat model versus the globe model, you're going to get different azimuths. And I believe that's how they figured it out. In other words, they used communications. They had all that, they have all the government has all those resources. But now we know it's not quite what we've been told. I need to send somebody out to the south to go and figure out, is there an edge? In other words, is this place enclosed?
Mm-hmm.
And I think Byrd found it. Now, okay. Byrd talked about a lot of things that they found down south, and there's some talk, is going Nazi hunting. I think they just kind of used that as a cover. And yeah, that was kind of a sidebar, but I think they went out there to find the edge, the limit. And I think they've lost aircraft and equipment finding it. In other words, when you run out to that edge, if you look at a C-47 and the distance that a C-47 can go is about, if you lose extended fuel, you can go out so many, 2,000 miles or whatever, you're going to have to turn around and come back. I think that the edge is somewhere beyond right at 1,600 to 2,000 miles inland from that edge, that exterior. And I think they probably ran into it or they lost some aircraft and said, yeah, that's the end of this place. Now, that's me just speculating. Why would they send Byrd down there with all those people? Again, that's my analysis of that. So.
Okay. I mean, right. Maybe. What I think you ought to do is to practice that critical thinking, right? Is just say, hey, I think it's something like this. I think this is what's going on. Or take whatever you think is going on, right? If you don't think it's this map, take what you think it is. And then like on the equinox is an ideal time to do this, really. Mm-hmm. Draw your map just like this. Draw a straight line, east and west, best you can, right? Best you can from your location. What is due east? I don't know. I'm trying to draw with a mouse, so it's all crooked and crappy, but you'll get out a ruler and you do it good, right? Like, that's due east. And I know that on the equinox, the sun will rise in the east. Okay, so that's where the sun's supposed to rise. And then you say, okay, from my position, there's noon, 11, 10, 9, 8, 7, 6. What time does the sun rise? Here, here, here. And then just test it. Don't take anything fancy. Anybody can just do this completely free. Just get yourself a compass and measure the bearing to the sun. Just eyeball it, right? As you can see, you could be within.
You'd be surprised.
30 degrees.
You'd be surprised at people that don't know how to operate a compass.
Indeed. Indeed. But I trust that you could do it, right? So why don't you do that on the solstice? And you tell me, does the sun rise north of east? I'm sorry, on the equinox. Does the sun rise north of east on the equinox? And since you have your precision devices, why don't you tell me exactly what the azimuth is and tell me how far off from the prediction? What is the prediction? That's the thing. You make a prediction based on your understanding of the model. This is my understanding of a flat Earth model. Make yours, right? Make your model. Make a prediction, and take a measurement, and come back and compare. And I'm saying you're going to be off by tens of degrees, like not even close. Like who cares about the precision? You're just so far off. And then look at what the globe predicts, which the globe predicts for that day is going to be east. And just see whose model is better.
Yeah, you're using the exact same comments I use about the sun height for the globe. It's so far off that it doesn't really matter. So now,
right.
If you look on the, if you look at the printout that I gave you on number 12.
Okay, let me just.
So now this is for the US.
Okay.
Now, if you look at those azimuths, those are azimuths from my place in North Carolina. That's a westerly read and an easterly read.
Okay.
So easterly time was, I think, right around 09, and then westerly is 1500, so 3 p.m.
Mm-hmm.
Now, when we look at that based on the sun size and the flat Earth model, what you're actually talking about, does that fit in with the flat Earth model? So, in other words, bring up
Right.
the flat Earth model. Okay.
That one.
Now,
Put a
if you
couple
look
thumbs on
at
it.
where my reading was southeast, when you look at the small sun on the flat Earth model, is it southeast? Yes, it is. In other words, now is this map correct? And this is where we start to have issues. In other words, we know that this map, there's some issues with it. So in other words, because the sun is so small, you're talking about your distance, okay, is going to change. And that's something that this map is going to change. So it's a start. This map is a start, but is it accurate? You know, I question that, especially if you're looking at an object for the flat Earth map. So when we look at that, what you're saying is, if you look at that sun position right there, not the bottom one in Africa, but the other one in South America,
Mm-hmm.
and that's kind of along that azimuth at 9 o'clock. So in other words, you know, that's a southeasterly reading if you look at the map from the globe Earth model.
Mm-hmm.
Now you position that sun a little bit back, and is it at an east when you see it at an easterly reading? And you can say, yes, it is at sunrise. It's a direct east. So now that just kind of goes to that point, the sun position and the distance. So you kind of see the different in distance in the azimuths. Do they match up? Sure.
Do they?
Yeah.
I think I just showed using my math. Using my map.
Okay, now look at the continent position now, the U.S., and then look at your left and right lines where they're going up. Now remember those
this one here?
Yeah.
Okay.
Yeah, left and right. Those are left and right azimuths. So now that's at the one at the right is at 9 o'clock. The one at the left is at 1500 or 3 p.m. in the afternoon. So now go back to your flat Earth map. Now look at the position of the continent of the United States.
Yep.
Now look at your position of your sun is at.
Okay, so at 9 o'clock, well, let me see. For you were about here. Am I in the right spot?
So at 9 o'clock, you're actually going to have that sun right close to where you have in that position. Now, the earlier position is going to be back towards more direct east off of the United States.
Where are you? Are you about here?
Yeah, go straight down now. Straight down.
Let's go straight down from there. I got to go back to pen. So this is noon for you, right? Sun should be along that line.
No. Go straight east. Straight east from the
straight east is 90 degrees from that.
Yeah, right there. Okay, now right there at that meridian. So that's going to be your 6 o'clock or right close to your 6 o'clock or your morning, your early morning.
These show the angles, right?
These are July readings. So
1, 2. Do you want the July or do you want the?
No, that's what I'm telling you. So when you shoot these azimuths, the ones that I'm telling you, these are from July. So this is a summer reading.
Right. So the summer will be a smaller circle. Okay. And so this is 1 hour, right? 1 hour is right here. 2, 3 hours. Right. This is what you're talking about at 9 o'clock. 9 o'clock should be right about here is where the sun should be, I'm saying.
No, it goes from east to west. So you're going to be where 9 o'clock is where your sun is right there.
9 a.m. is here on your model.
No, that's 6. So from your bottom line that you draw, that's 6.
Each one of these from here to here, that is an hour, right?
Well, look at your bottom ones. You got 3 hours right there, right?
1 hour, 2 hours, 3 hours. So this is 3 hours before noon.
Look at your easterly, okay, which is your one to the right of that right there.
This.
Yeah, that line right there. No, that line that you drew out, straight east.
This.
Straight
yes.
east.
Yes.
Okay, so straight east, and now you take it to your other line where where the sun is at. You're looking at southeast, which is what you have on that reading at 9 a.m. on the position where I showed you from the U.S. So that's pretty close.
Okay, but check it out. This up down line is due east.
Yeah, that's at 6 o'clock.
This is due east.
Huh? Yeah, that's what I'm talking about. So that'd be sunrise.
Okay. This is due east.
Sunrise.
This is due south.
No, that's southeast.
That's south.
Southeast.
Not from that point. That's south.
Yeah, it is.
How do you figure? These lines go from the North Pole to the radius. So
look at your
this is south.
Look at your grid line. It's southeast.
Every one of these radial lines that go outward from the North Pole are southbound lines.
Yeah, that's what I'm saying. So when
this red line that I drew that I'm highlighting,
yeah, that's what I'm talking about. So
that is due south.
Yeah, this is what I'm talking about. So why we know there's some issues with the flat Earth map. Yeah, we understand that. And again, but your sun is still southeast right there in that position.
This sun.
Yes.
Yes. Yeah, I'm not talking about this sun. I was talking about this dot. Yeah. This dot is where your model says the sun should have been.
No.
9 a.m.
No, dude. You're going from east to west, dude. Come on now, get your heading right.
Oh, okay. Here's where the sun is going to be at noon. The sun will be there.
Matt.
Correct. Just help me with this, right?
Go from the 6 o'clock position due east.
When you say 6 o'clock position,
look at the line going down.
Yeah.
Going straight off the East Coast. Go to that line. Go at the meridian. Go to the meridian right there. Right there.
Wait. You want to go? The meridian is right about there. 23.5 degrees. Okay.
So you're going to see that sun as the sun. Okay, comes back. Now that's at 6 and at 9.
Wait. No, that's not at 6.
Yeah, it's going to be sunrise.
Let's start at noon. Noon, I think we can agree because it's easy. This is noon. Due south. Right? So there's the sun right where my laser dot is at noon in the summer from you. Right? Due south. It's along the southward line at 23.5 degrees up off the equator.
Now you're going to be a little bit to the right.
Okay, am I not at 23.5 degrees?
You're still southeast.
This is due south. My laser dot, not the sun, my laser dot.
Yeah. So between that dot is 9 o'clock when we take the measurement. If we look
so we now have to rotate back 45 degrees, right? So it's 15, 30, 45.
Mm-hmm.
So this is 9 o'clock on the flat Earth model.
Yeah.
I rotated 45 degrees back, right? The sun goes around in this circle. One of these sectors, an hour, right? Each of these is an hour, I think. So there's 1 hour.
Mm-hmm.
Okay, it's on this latitude. So there's 1 hour, 2 hours, 3 hours. That's 9 o'clock. 4 hours, 5 hours. This is 6 o'clock.
So now look at your other azimuth line from where I drew, and look at the end of the line.
Yeah. Okay. So at 9 o'clock, right? At 9 o'clock, let me draw you the line that we think we're going to see. At 9 o'clock. Oh, come on. Yeah. Oh, that's pretty bad. Let me try again. I'm doing this by mouse.
Yeah, I get you.
I'm not trying. I'm really not trying to be dishonest with this.
No. But and
Oh, I did it again. Oh, that's pretty good. Okay. Which, as you can see,
Mhm.
is north of east. I mean, this is just by eyeball method. You have to be much more precise, right? But would you not agree that the line I just drew is north of east?
that line, what are you talking about now?
This line right there.
Yeah.
That's north of east, because this is the east line. There's the south line. That's the north line. Oh,
Okay.
that's a bad north line. That's the north line. Let me erase that other one because it was crappy. It has to go through the North Pole. Duh.
Mm-hmm.
Right. And so I'm feeling like maybe I was I could be more generous and I could move the east line a bit more so that maybe this line could be the east line. Maybe that's due east. Try to be more generous to you.
Yeah. So I get what you're trying to do, but then again, when we say that, we know that this map has some issues. That's one of them. In other words, we have to look at sun position. This is why I said we can use the sun to create a new map, and I made that in my comments. So when we look at this, now look at
what you measured. Let's go back to that. What you measured was decidedly south of east, right? Not like south. Borderline. It's like no, that's south of east.
That's southeast, Matt.
Well, right. East, southeast. Maybe I'm trying to be a little generous to you.
Azimuth. So again, you look at how far that line goes across the Tropic of Cancer.
Mm-hmm.
So again, we know there's some issues.
Right.
Yeah. So it identifies it. Now, what do we do with that?
What do we do with that?
Interesting. It brings up some interesting things because look at how it's canted, right?
Uh-huh.
So now, is this model correct?
I would like to point out that again, you were extremely critical of the globe Earth model. It's like nitpicky, like trying to measure really precise and whatever. And you don't seem to have done that same critical approach towards the flat Earth model. And with the flat Earth model, we see that it's wrong, and we say that there's problems with it.
What we look at, and this identifies. Well, look at your sun position at the end of that line. You know where it's at.
Uh-huh.
We look at, well, that sun should be right at the Tropic of Cancer. So again, we understand there are some things that we need to look at. Is it correct?
Right. So what I'm saying is, when you measured, according to your analysis, you measured that the sun was 6 degrees out of position for the globe. You said, it's 6 degrees out for the globe. And you're like, aha, globe is valid. We're looking and we're seeing, 30 degrees out of position for the flat. And you're like, well, there's problems with it. Do you see how you're applying a different level of criticality to those two?
We don't know that we have an accurate map. So, in other words, we have already identified that we don't know that we have an accurate map for the flat Earth map. So now what we need to do is look at data, okay, which tells us yay or nay, or, what are these? And that's why I talk about the sun. You can use the sun to look at creating a new map or what it is we're actually on. That's going to take a while. So in other words, that's a huge project. Now, will I see that in my lifetime? Probably not. Again, so then we have to look at these readings. What do we get? What do we come? And again, these are just two readings. I look at easterly and westerly.
Okay.
So,
all right. Rob Parks has a question here. If the globe model is consistent and predictive, yet the flat Earth model has problems, why believe the Earth is flat?
That's a great question. Why?
Why indeed? I mean, because what I showed you was like a 3D simulation,
Mhm.
and I can use that 3D simulation. I have a handful of them to predict exactly where the sun should appear in your sky any given day, any place of the Earth. I can do that using the globe Earth model, and it'll work. It'll be right. I can get you within a degree.
Well,
Okay.
that's in accordance with what you're explaining.
My model that I made myself, I have a model that can get you within a degree of where you're going to observe the sun. And I'm willing to put that to the challenge at any time.
Mhm.
Your model so far, we just agreed it has problems. It has problems. It's maybe 30 degrees off, right? Maybe 10, 20. It's a big chunk of wrongness currently. What makes you think that your model has any merit at all compared to my model?
That's a good question.